Hello everyone, thank you for joining us today. My name is Jenny and I'm a part of education team at Medit. Nice to meet everyone. And today we have Dr. Andrew here.
Hey,
Hello doctor, how are you?
yeah, not too bad, not too bad.
So glad to see you again. Thank you for joining us for the second time.
Yeah, always a pleasure.
Hmm. So I think today's topic seems really interesting.
Yeah, this was a really fun webinar to record, I have to admit. Usually, because I do quite a lot of education, it does get a bit dry for me, but putting this together was actually quite a lot of fun, and seeing that what you can do with the software
Yeah.
was really quite we've come a long way in such a short period of time when it comes to software. So yeah, this was really a great experience for me to record this webinar.
Hmm. So since your specialty is about 3D printing, so what's your favorite app among Medit's free software?
Yeah, I think for me, the 3D printing is just, bringing your imagination to fruition. So if you have an idea or you have something in mind or you have an application in mind, the 3D printer is just there to bring what you have in your mind into physical form. So for me, actually, I mean, I love 3D printing. I do it as a hobby. I did it as a hobby first before I, introduced it into my practice. For me, the 3D printing is actually quite straightforward, especially in dentistry. I think dental 3D printing is quite predictable. But actually, what is most engaging or thought-provoking from my point of view, and probably what's more important in the long term, is actually the design. Okay, bringing your ideas from your mind into a digital environment like Medit Design or Medit Clinic CAD or Medit Splints, and then from that digital environment to translate that into a physical form, which is basically where your mills and your 3D printers come from.
Yeah. Okay, so I'm very excited. So shall we get started?
Sure, absolutely.
Okay.
Thanks for tuning in today. I'm Dr. Andrew Ib, and the topic for today's webinar is thinking outside the box. So we're going to be looking at unconventional uses for Medit apps. And I'm a big fan of Medit software because it's free to use. If you want to follow what I do on any of my social media, the link or links, I should say, over there on the screen. You can scan that QR code and it'll bring a whole list of all my relevant material. So once again, if you want to follow anything that I will go through today in this webinar, then by all means, the links are there. I also run a free to watch and subscribe YouTube channel where pretty much all of the videos that you'll see in this webinar today will be shown. So I hope you get some inspiration from today's webinar. It's a very interesting one, and it's just going to be showcasing some cases where you might not have thought this type of software was capable of achieving. So yeah, let's get straight into it. A little bit about me, in case you don't know. I'm a Sydney-based general dentist in private practice. I've got a list of boring credentials over there, so I've spent a lot of time furthering my own education in orthodontics, in implantology, and in digital dentistry. So I run workshops all over the world, in Australia, in Southeast Asia. I've spoken in the US. So yeah, this is it's really been a privilege to speak on behalf of Medit on this particular topic. I currently operate a number of 3D printers myself. Actually, my, I guess, field of interest is actually 3D printing. So I've actually operated over 25 different 3D printers so far. And of course, I started all of this as a hobby at home, looking up on YouTube, Facebook, very, peer-reviewed sources of education. I think nowadays, digital dentistry education has gotten a lot better. But I guess that's where I started off with. So as you can see on the screen on that top right-hand side image, that's really where I got started, printing out toys and models and of course helmets for my cats. And I guess these days I'm, most of my 3D printing is actually dentally related. Just another self-plug, I guess. My YouTube channel where pretty much all of the playthroughs for this webinar will feature in. AI 3D. Make sure you search up AI 3D and just put in dental, because if you just simply type in AI 3D, you'll get some pretty random things on YouTube. And of course, my Instagram page as well. I'd like to thank any webinar or talk or workshop that I start off with a bit of thanks. So obviously a bit of thanks here to my parents, who are both dentists themselves, but generally not very digitally savvy. And to this day, I still pretty much do most of the digital dental work at the practices. And of course, the loves of my life, my wife Casey, and my 2 cats, Max and Minnie, who will feature throughout this presentation as well. The image on the left-hand side is actually a photo of a 3D print that I've done. So it's a multicolored 3D print, and it acts like stained glass. So when you put it on some light, you'll see the colors shine through. So a bit of a thanks to my parents and my lovely wife Casey, and of course my cats, Max and Minnie. So yeah, as I mentioned at the start, this is kind of like where I started from. Silly things like this. These are 3D printed helmets for my cats. Minnie's on the left and Max is on the right. And some multicolored 3D printed artwork as well. So I was doing silly things like this. And nowadays, most of my 3D printing is stuff like this, like on this photo, where we have some provisional implant restorations. We have the abutments, customized abutments that is 3D printed in a clear split material. And for the aesthetics, I've also had my designer design a facial veneer that is actually bonded onto this clear abutment. And this clear abutment allows me to see the healing underneath, and the veneer, of course, preserves the aesthetics. And of course, just to prove a point, these are the 3D printers that I am, as of right now, as of this recording, those are the ones that I've actually had in my office and utilized myself. So, software, dental software. There's a ton of variety out there, and of course today's webinar is going to be focusing pretty much on the apps in the Medit, I guess, environment. But there's so many different options out there. I think many users will know ExoCAD, 3Shape, those are the big ones. Blue Sky Bio is very popular for surgical guides, and then you've got some smaller players like Blender for Dental, Clinics, DentBird AI, who I also have tried out a lot. So there's a lot of programs out there, and realistically, it's not a one-size-fits-all situation. It really depends on your practice or your lab, what it feels comfortable for you to use, how much time you want to dedicate to digital design. I use a lot of Medit apps because, of course, it's free, and it's a very versatile, I guess, a suite of software options. So yeah, I'm a big fan of what Medit has come up with, and of course, I'm very excited to see what they come up with next in the next 6 to 12 months. So when we talk about software, there's multiple different types of software. Of course, today's topic, we're going to be talking about design software specifically. But then if you're 3D printing or you're milling something, then, you have your own respective CAM software for that. And that, how they look and how they operate will be different based on the system that you use. The purchasing model that you purchase these software programs is also, very different. As I mentioned before, Medit software is generally free, but there are other programs that either are a one-off purchase, or you subscribe and you pay some sort of monthly or yearly fee. Or there are other programs that you actually just pay for the export. So it's free use, but you just pay per export or per job, essentially. I'm a big user of Medit scanners, so of course it makes sense for me to use the Medit software, because the transition from intraoral scan to design software is quite seamless. That being said, you don't need to necessarily be a Medit user or Medit scanner user to be able to use their software. It's free to, at least as of this recording, free for anyone to use. So yeah, if you want to dabble into it or try a little bit, by all means, give it a shot. You have really not much to lose besides a little bit of time. And of course, this is a table. I'm not going to go through this table in a huge, great amount of detail, but it just goes to show the variety that exists within the whole industry of dental software. They can be very expensive, all the way to completely free to use, like Medit. 3Share, Exocad, very pricey options, but very, very powerful. But every time you have to update something, you have to pay a certain fee. It really depends on your clinical or lab environment, whether that business model makes sense to you. Very, very importantly, before I go on to a number of cases, and the meat of this presentation will be on cases, is make your life easy, all right? Don't skimp out on your PC for digital design, whether it's dental or graphic design or videography. Any of this type of software requires a very powerful processor and a lot of RAM and a very good graphics card. And the better specs that you get in your PC or your laptop, the smoother things will run. And it will just basically make your life a lot more enjoyable. Whereas if you kind of like skimp out on the software, then often the loading times will get you, your program may crash. It just won't be a pleasant experience. And at the end of the day, with dental design, you really want to spend as little time as possible in front of a screen. As a dentist myself, I build the most when I'm actually seeing patients, not when I'm actually designing something. So I would strongly recommend that you do get a good PC if you are seriously contemplating on using dental or digital dental software, because it will just make your life a lot more pleasant. The good news about Medit software is that it is Windows and Mac approved. There are some programs out there that are only specifically for Windows, but the good news is that Medit apps are generally compatible for Windows and Mac operating systems. All right, so let's start with a simple case, okay? We're going to talk about some provisional implant crowns that are going to be screw retained, and I'm going to be using Medit CliniCAD. And I think Medit CliniCAD has a lot of users, but I think a lot of the functions actually get missed out. So this is a temporary abutment that I've just covered in composites, and you can see the screw channel there. And actually, you'd use Medit CliniCAD in this case actually no different to a crown preparation, actually. So the application would be a crown, and you'd design it like a crown. The only difference is that unknown to many existing CliniCAD users, you can actually create a screw channel. So here in this case, I've actually mirror imaged the tooth next door. Once again, one of those functions that users seem to kind of like forget it exists, but it certainly does exist. It is actually really powerful and really nice software, considering that at this stage it's free. So here I'm adding a screw or the channel, trying to line it up as best as possible to that screw. And there's a bit of guesswork involved, all right? You'll just kind of have to adjust it. And thankfully, this is a temporary prosthesis, so I can add, subtract in the mouth quite easily. It doesn't need to be picture perfect. So once I've generated my crown, I can basically cement that onto my temporary cylinder. Here I'm printing it, 3D printing it on the Asiga, and then we polish it. We polish it to a really nice shine. These materials, these temporary crown materials, are nowadays radio opaque, so you'll be able to see them on an X-ray. And this is kind of like the results. So this is a nice, simple case to get your appetites a bit whetted, because the next number of cases will be quite a bit more in depth, right? So once again, just giving you a bit of a teaser to show you what's possible. Medit CliniCAD isn't just for crowns and bridges. You can design a whole lot of other things with it. Right, and another case. These snap-on smiles are very popular for try-ins. You want to show the patient, what's possible, what their potential future result may look like. And I'm actually using Medit CliniCAD in this particular scenario rather than the Medit Designer. So here, I've got 4 front teeth. I want to do a 4 teeth snap-on smile. So I'm designing essentially a bridge per se. Okay, and the teeth have been prepared. Well, not really, but I'm allocating it as a prepared data. And then you just basically mark your margins. You would definitely want to bring your margins lower. So here, I have definitely brought the margins on the facial aspect right down to the gum line. And then in the palatal margin, I've actually brought it down to kind of like halfway, just to kind of trick the software to allow us to create something. If you end it too shallow, the software just doesn't detect the margins at all, and it kind of bugs up. But here, you can see splinter bridge. You can use sculpting tools then to modify the design accordingly. And then you would basically 3D print it and try it in the mouth, right? So it's very simple. You don't necessarily need to have Exocad or 3Shape to do this type of work. For simple cases like this, you can absolutely use Medit CliniCAD. As I said, you'd basically trick the software into designing a bridge per se, but you would end your palatal margins kind of like halfway onto the tooth. Now, if you're finding it difficult to kind of see into the teeth, then because it's 3D printed temporary material, you can cut it back, you can adjust it. It's not rocket science. Yeah, so here I'm spending a bit of time using the sculpting tools to really edit it, make it look as nice as I can. But once again, it's not going to be a permanent prosthesis. It's just going to be a quick temporary to slot in the mouth and show the patient what they may be looking at in the future. So it's a great selling point, and because it's free, you don't really lose much besides some time and the material cost, of course. So here I'm printing it out of Onyx Tough 2, and this is the result freshly printed. This is what it looks like after it's being cured, and then I characterize it just a touch, just to give it a bit of life, right? And just basically pops in, and you can show the patient, this is just to give them an idea. Yes, this is what we can achieve if you go ahead with treatments. So just one of those smart little ways of using the existing software to your advantage. Right, and this is such an interesting case. I do have to thank Dr. Caroline Cattell from the US. She actually created this technique where we're actually we're combining analog and digital modalities. Anyone who does a lot of anterior composite work knows that it can be quite technique sensitive. It requires a lot of practice, and it's often one of the challenging parts or stages of this type of treatment is creating that thin palatal shell on which you will place your composite onto that. So what would happen if we could design and create and 3D print a palatal shell, right, that would be cemented onto the tooth, and that may be incorporated with the final restoration. And that's basically where Dr. Cattell came up with 3D freeform. So it just marries this digital technology where we have 3D printed palatal shell, which you may incorporate the contacts in already. So you don't even need to worry about fiddling in with matrices in the mouth. And then you would layer onto that particular shell your composite for your aesthetics. Because currently, right now, 3D printed definitive restorations are quite opaque. But if you're layering onto that your traditional nano filled composite, then you have something that can polish well and looks very nice. So let's go through this particular case. So we had this gentleman, he had a fall and he broke the tooth, and the tooth really required endodontic therapy. So while all that endodontic therapy was being done, we had this palatal shell design, which, it's just kind of like killing two birds with one stone. You can teach your assistants or your lab techs, if you have one in-house, to do the design while you're doing this type of work and focusing on the endodontic work, as is the case in this particular situation. So this is going to be a powerful shell, all right? We're not looking at creating something for the aesthetics. We're basically creating a shell onto which we can layer our composite on. So yeah, just marking the margins. You can see the temporary, restorative material, sealing that access channel. So yeah, positioning that tooth. I didn't decide to mirror the adjacent tooth in this situation because I wasn't really happy with the shape of that tooth and the position of that tooth anyway. So yeah, we use a tooth from one of the stock libraries available in Medit Clinica. And then here, we're just basically using our sculpting tools to manually remove material, right? So our contacts are sorted, our palatal shell is sorted. We just need to make sure that we have enough thickness for our 3D printed resin. So generally, you don't want to go any lower than 0.3 millimeters thickness for 3D printed restorations. It can be quite challenging to print dimensions thinner than that. But yeah, here I'm just you can see like the area available for me to layer on my composite, and because these printed resins are kind of like hybrid ceramic hybrid resin materials, you can actually bond onto them quite easily. So in this particular situation, I'm keeping or retaining that palatal shell. I'm not removing that after I apply my composite. That is going to remain as part of the final definitive restoration. Now, eventually, that tooth probably should be crowned, but for now, I've decided to go ahead with this particular treatment because of budget. This patient had a fall at a work site, and so he's going to be potentially claiming part of this treatment through insurance or workers' compensation. So, but in the meantime, at least I'm trying to give him something to work with. So that's the final design. And we're going to, of course, 3D print this. I'm going to be printing it in a couple of different units. First, I'm printing this on the Hagear's chairside unit and out of Ceramco Crown Tech, which is a product that has been in the market for now a number of years. So it's got a lot of clinical data and quite a lot of users out there, especially in Europe. So it's quite a nice material, polishes very well, prints very, very well, and quite predictably on a whole range of validated dental 3D printing systems. So this is my shell. We generally want to orientate it with the incisal edge facing the build platform, which is what I'm doing over here. And then, of course, when we add supports, the supports will be on that incisal edge, but also on the palatal surface, which we can polish off. It's quite straightforward to do so. So that's basically what it looks like when it's nested. I believe I add a few more supports just in case, for security. And then, so once that is done, we can send that off to the 3D printer to print. Basically that's what it looks like when it's freshly printed. In this case, I printed it at 50 microns. You can print it at 100 microns and essentially halve the time. I'm actually printing it on the Nexa Zip. It's another 3D printer out in the market. Quite a nice system and very cost-effective system as well. So I did a bit of testing for this particular company, and it was quite a nice system to use. So once again, I'm orientating that prosthesis with the incisal edge facing towards that build plate, and of course with supports. Yeah, and here I'm actually printing two of them because you never know. You can drop one, lose one, break one. At least you'll have a spare at hand if that ever happens. The material cost per unit is actually very, very low. So especially at the start, if you're doing this, if you're new to 3D printing, then I would strongly recommend that you print multiple copies of this type of work, crowns, bridges, veneers, at the same time, because if you happen to lose or break something, then you have something that you can use straight away. Right, so that's my palatal shell. Fully polished outside of the mouth, so it's all done outside. I've aerobraded that surface where the composite is going to be bonded onto. Yeah, so just to maximize that bond. Yeah, so yeah, that's really what it looks like, and I've cemented it out of Panavia V5 Clear, which is my go-to for cementing 3D printed restorations. And then finally you apply your composite on top, and then of course finish it with a nice polish. So yeah, interesting use once again of the Clinic CAD app. Now, some more advanced, I guess, exercises, bleaching trays. So, of course, traditionally, if you wanted to just, create a bleaching tray, you'd have to 3D print a model and then create, pressure form or vacuum form some sort of blank onto that. You can actually design 3D printable bleaching trays using the Medit design app. Basically, you first of all load your scans, create some sort of offset model by about 0.1 millimeters, and then essentially, if you want to edit your tray, so if you want to add little reservoirs for you to apply the whitening agents, then you can use these sculpting tools, which is basically what I'm doing here. And then after all of that is done, you would basically trim what you don't want. All right, so you really take away most of the material. Here I've used the auto tooth select function, and essentially I'm just deleting the areas that I don't need. So we don't need most of the palatal surface. We really only need it for seating essentially. Yeah, I'm trimming these areas where the retainers are, because we don't really need that, and including them into the final prints that actually complicates the geometry, so it's actually harder to print successfully. So actually a simpler appliance actually makes for a lot more predictable printing. So because these are bleaching trays, we don't really need the posterior sections as well, but yeah, I'm using these brush tools to manually edit the design and incorporate really only what I need. Of course, once this is done, so here I'm working on the upper tray, then you would use a thicken tool to actually thicken this offset model, or the trimmed or cropped offset model. So I guess the really important thing about the Medit design app is that it's actually very powerful software and very versatile software, but you kind of have to know what you're doing. There's multiple tools that you have to be familiar with. So of course, your trimming tools, your sculpting tools, so you can add, remove, smooth, you can morph or basically pull certain areas back and forth. And then you got your offset models, offset function, your thicken function, and very, very importantly, you have a Boolean function where you can combine, subtract, or intersect different meshes. So here I've done the upper, and of course you would repeat the process for the lower. And you'd want to print them at least 1 millimeter thickness, and you'd be using a soft splint material like Key Splint Soft, either the original version or the clear version. So either or, but any splint material, soft splint material will work. I wouldn't use a rigid splint material because at that thickness you can easily snap them. You're really only just printing them at 1 millimeter thick, so yeah, you just got to be careful using a rigid material. So yeah, here I'm working on that lower tray, just adding small little wells using the sculpting tools where my gel will essentially sit down. Now that's an optional step. Some dentists or technicians prefer to have those little wells, but I actually personally don't. But for this playthrough, I have included that step if you wanted to kind of follow on and do that, if that's your preference. Once again, cropping the stuff that I don't need, and trying to keep those edges as straight as possible. And it'll make more sense when we actually go and actually 3D print these, because those nice straight edges or borders will actually print a lot nicer than something that is a bit more scalloped. As I said, you just want to simplify the geometry as much as possible. So I wouldn't completely trust the software, as you can see here right now. Even though I've used that auto detect function to select the teeth, it's missed out some areas. Okay, so I wouldn't kind of like blindly just follow the software. At the end of the day, you're in control. You really have to know kind of like what you're doing and modify what you receive from the software accordingly. It's not perfect, but considering that it's free software for more or less anyone to use, I like the user interface. It's nice and clean. I think other programs like Mesh Mixer can be, it's not easy to, it's just not pleasant to look at. Whereas this is quite easy to, it's quite pleasant on the eyes. So yeah, here we're thickening it, and I think that's basically it. All right, and then we can go ahead and 3D print these. And in this particular case, I'm actually 3D printing them on the Sega Max UV. It's one of my favorite 3D printers, and the reason why I'm printing it is on this particular unit is that they have special trays. So the ultra gloss trays where you can basically print them. If you minimize the amount of supports there, there's actually almost no post-processing involved besides washing and curing. The good thing about this particular software or nesting software for Sega units is that you can actually sink the prints lower than the build plate, which is what I've done here, rather than using supports. So I'm actually deliberately trimming the back part of that tray, okay? And this is basically what it looks like freshly printed. So crystal clear, they fit like a glove. So it's just one of those things that you can use with your Medit apps. Mouth guards. Another, I guess, similar exercise. Once again, we have some scans. We're going to use the Medit design app. And essentially, this is not a terribly hard exercise to do. You're just basically creating, once again, a shell of your intraoral scans. You should probably create some sort of offset model first. But right now, essentially, I've selected the teeth, now we're just kind of marking the borders or your extensions for your mouth guard. And then it doesn't need to be that nice because you can always polish it afterwards. What I would strongly recommend though is if you're going to be 3D printing them, you definitely want to design them with at least 3 millimeters of thickness. At anything less than that, they're a bit flimsy, and there's not too many mouthguard resins out there in the market. Really, from the top of my head, there'll be one from Coulter, and the other popular one, I guess, is the one from Keystone Industries. So that's Keyguard. Comes in a black and white color. I think they're coming out with new colors as well. But yeah, here, here we just basically create. I think I created a 2 millimeter thick shell here, but I would generally recommend if you're going to do something like this, print it or design it at 3 millimeters thickness. What I'd also do is I'd actually probably create the offset model first. Rather, here I'm actually doing the offset second, or following after I created that thickened layer. These days I would actually create the offset model first, and then based off that offset model, create your mouth guard. So yeah, printing out of key guard, it's going to be a very long print because it's going to be orientated vertically, and there's going to be a lot of supports. If you orientate it horizontally, there's a lot of post-processing. It's not fun to trim this type of material, so that's why I've orientated it vertically. But as a result, the print time is very, very long. You're often looking at a 3+ hour print time, so 3, 4, 5+ hours sometimes, because it's a very opaque material. So it's going to be a slow print. So this is something that you're going to be leaving overnight to print. And I guess why you would 3D print mouth guards, I guess it's in certain cases, if the mouths that you're printing or you're just having these mouth guards made for are going to be they're going to be changing quite rapidly. So if they're patients on braces or they've got loose baby teeth, so you're going to expect quite a lot of change in the near future, then yeah, I'd go and print a mouth guard for them, because it's you can modify the design quite easily digitally, and it's after it doesn't fit, you can just basically chuck it away and create a new one. Okay, another controversial one: printable retainers. And personally, this is not something that I would recommend for orthodontic retention. Actually, what I feel these work very well as are splinting teeth, splinting loose or periodontally affected teeth. So here, we got our scans. We're blocking out some of these interproximal contact areas so that our, retainer doesn't engage too much within those contact regions. So that's basically, I'm using the sculpt tool in this particular case. And just blocking out those contacts a little bit. And then you essentially want to trim everything that you don't want. So once again, using the brush tools, you're basically marking the borders of your retainer. All right. The one thing that I would note about this type of work, or using printing retainers or splints for periodontally affected teeth, do not make them too thin. All right, they will fracture, and it is not easy to remove them because they will be bonded to the teeth, and you essentially will have to drill them out, right? And you'd use a little bit more of a flexible type of material, so you wouldn't be using a highly filled definitive crown resin like split ray ceramic crown or rodent sculpture where the ceramic filler is over 50%. You'd use something like Onyx Tough 2 or Bago Trinique or Rodent Titan, where the ceramic filler is less, but as a result, the material has a bit more give and flexibility, all right? So yeah, once again, these days, I'd actually create the offset model first and then base my design on this. And I'm giving this a little bit of thickness, about 0.8 millimeters minimum, okay? So you do not want to go anything less than 0.7 because they will fracture, and then they're not pleasant to clean up. You've also noticed that there are 3 little sprues on this retainer. All right, the reason for that is that they will actually help me seat the splint in. So actually, that's one of the really nice things about digital design. You can design whatever, more or less whatever you want. And this is a way to help me actually seat my retainer in, and then once it's bonded, you can just basically drill it off. Okay, very eloquent, very nice, and very quick way of designing something that you can design it and have it made indirectly, and then you just pop it in. Very easy to bond them in. Okay, an extra step, I guess, in this video is that I actually create little wells on the fitting surface of this retainer. And that's basically where you're going to apply your cement. So you can, it's very easy for you to kind of like know where to apply the bonding agent and the cement, so there's less cleanup. Once again, we're trying to find out ways to reduce the amount of cleanup that you need to do, and this is just one of those ways that you can. Once again, Medit design showing that it's quite a versatile app which you can do a hell of a lot with. All right, and definitely, we're getting now to the more challenging exercises. So here we got a missing tooth, and we're going to design a little Nesbit, or some people call it Nesbit, some people call it Flipper. And here we've got a missing tooth, so we're actually going to copy the tooth from the other side, do a mirror image of it, and basically use it as our tooth. These days, if you don't have something like this, like if you don't have a molar on the other side, you can actually create a Pontic using Medit Clinic CAD. And often that is probably a little bit faster. But in the Medit design app, this is how I'm creating that little denture tooth per se. I guess the tricky thing with this particular exercise is that there's a number of offsets that you have to keep in mind. And offset being a gap between two different bodies. First, there's an offset between the denture tooth and the denture base, right? So this is going to be a two-piece denture or two-piece Nesbit. You've got your denture base and your denture tooth as separate bodies, which will be 3D printed separately and then bonded together. So there's got to be a bit of a gap between your denture tooth and denture base, and then there's got to be a gap between your denture base and the surrounding gum and teeth, right? So that's two gaps. And then you also have to consider the occlusion as well. So the gap between your denture base, your denture tooth, and the opposing occlusion, right? So it is a bit of a tricky exercise. Essentially here I moved my my pontic over to where I needed to go. I was a bit vigorous and aggressive removing the material, so I've actually over removed it. So I have to kind of like re-edit, fix up the mess that I created per se. And you're using, once again, these tools in Medit design: add, remove, smooth, and your Boolean functions, your transform functions. The transform functions was what I used to move that denture tooth from the other side to the 4/6 of the lower right molar region. So Medit design is really about familiarizing yourself with these different tools, right? And of course, you can do quite similar work with Mesh Mixer, but as I mentioned, I like using Medit apps because it's just nicer to look at. It's just a clean user interface. Here, I'm actually deleting everything and just keeping what I want incorporated in my little Nesbit. So we're going to essentially delete these teeth, except for certain areas where we want the denture tooth to sit in, and we've got these little retention clasps on the sides as well. Now, you can spend a lot of time doing this type of work, or you could basically 3D print it and polish it accordingly. Okay, that's the beautiful thing about using dental software. You can do a lot with it, and I use a lot of it, or you can do kind of like the bare minimum and then create what you want to create and then polish it once it's been created. If you make any mistakes, you can always go back and to where you were and change things accordingly. So here we're creating a bit of an offset here. Well, I should say a thickened area. And yeah, for the denture base, I've put it at 1 millimeter thickness. You actually probably want a little bit more, maybe 1.5 millimeters. You can always thin it out once it's been created, but yeah, I think in hindsight, creating it with a little bit more thickness actually it's actually a lot easier to print. So this is my final denture tooth, and then we're going to create an offset version of that, which we're going to use to cut into our denture base. And so that there's going to be a little bit of a cement gap between our denture base and our denture tooth. And here I'm just, once again, this step, purely optional, just smoothing certain areas. There's a little actual island there, which I've had to delete. But yeah, just smoothing the borders so that you don't get such a rigid or snap fit. We want a little bit of give. Yeah, just once again using the smooth tool over here. But we're almost done with this particular exercise. And as I mentioned at the start of this webinar, if there were any things that you wanted to go through, like if you felt that the videos were a bit too quick, it's actually all on my YouTube channel for anyone to see and view at your own leisure. So yeah, here I'm actually creating a 1.5 millimeter thick version of my little flipper or Nesbit. That's going to be basically my base, and then we're going to actually crop out my denture tooth. And then we're going to use the Boolean offset tool here. So we're basically cutting the denture tooth within the denture base, like so. Okay. Right. So that's more or less done. The only things that we're going to do now is actually adjust the occlusion. You can see that there's some interferences with the opposing arch with those little arms. So we're going to use our sculpt tools to actually remove those little interferences. Well, of course, once again, you could do this, in the mouth. But here, while the program is open, while I can absolutely see the interferences, then this is quite an easy thing to do. Okay. And then, yeah, you can. Here, I've mentioned you can additionally smooth more of the borders or the base, but sometimes you don't want to play around with it too much, and you'd print the denture tooth and the denture base separately. Before you put them through the post-curing units, you would actually bond them with the native denture resin and then run it through your curing cycle. Oh, and almost finished, but here we got, this is a nice exercise if you do a little bit of implant work and you want to, not even necessarily implant work, but you want to create some sort of temporary Maryland bridge. This is basically how you would do it, using Medit design. Now, in this case, I have a full set of teeth, but of course, in your particular situation, you may not have a tooth. Well, it should be missing. So in this case, I actually make a mistake here. I actually use the fill hole function, but you shouldn't actually do so. You'd actually use the bridge function to bridge as much as possible, and then you'd fill individual holes. And this part is a little bit glitchy. It's not perfect, but in the end, I do get away with it. And sometimes it requires a number of tries. Here, I've fixed up that holes, so you can imagine that's your extraction site. But yeah, I'm just using the sculpt tools. In this case, the smoothen and the remove tools to create that little socket, essentially. Now, you may use the tooth on the other side as a copy or a mirror image copy for this Maryland bridge. Or as I mentioned earlier, you can actually now create a pontic using the Medit CliniCAD app. You just allocate that missing tooth as your crown per se, and then you'd mark your margins on the gum, and then you'd basically create some sort of pontic via that method using the Medit CliniCAD app. But here, we're using the tooth on the other side. Use the Smart Select tool and then some brush tools to really choose what I want included. And then we're actually going to, mirror image that and move that to where we want it to go. So yeah, I guess if you get anything out of this presentation, it's that I hope you understand that software is just there. Software is just a bunch of tools for you to use. All right, it's up to your imagination and your experience as to how well you use that software. And just because it's free software, like Medit Design is completely free for anyone to use. Just because it's free doesn't mean that it's terrible software or it's useless software. As you can see, you can use Medit, the Medit Design app in a whole range of different functions that you may not have previously thought of before. It's just never being limiting yourself to certain constraints and always trying to think outside the box, thinking of what not just what can't or can be done, but more like how can I make this software work for me. That's a beautiful thing about Medit Design. I think sometimes with certain dental CAD apps, like even with Medit ClinicAD, you're really just limited to creating bridges or crowns or veneers or onlays, inlays, pontics in certain situations. But that's more or less all that you can do with it. Whereas with Medit ClinicAD, really it's just basically like any CAD software. It's not specific to dental. It just so happens to be in a dental setting. So yeah, just not restricting yourself to such rigid thoughts is very important when using this type of software, and really having a firm grasp of the tools and knowing what the tools do, your trim functions, your transform functions, all that's really, really important, because you can really unlock a lot of limits. And yeah, here I'm having a bit of trouble. There's a small little hole there, so sometimes it's not perfect, but yeah, I managed to close up that that hole. Just smoothing the borders here a little bit. I think often when that happens, you just have to kind of delete a certain section, close up the gap again. So we got a little pontic in the right place now. And now with Maryland Bridge, we have to design our little wing, right? Now, once again, with 3D printed restorative resins, you definitely want to print them at least, in this particular clinical situation, 0.7 to 0.8 millimeters thick, right? Anything less than that, they will snap like a twig. In fact, I feel that in this design, my wing was way too minimal. It should have been bigger. And yeah, once again, I probably should have created an offset model to start off with, rather than creating it midway during the design phase. So once we create, you know, this particular wing, and we're happy with it, as I said, I probably would have made it thicker, but if for temporary, it's okay. Print multiple copies just in case it does snap. Then at least you'll have something to replace it with. But once you do basically have the tooth and the wing, you can actually combine the two. Right. Yeah, I think I tried the Boolean combine tool in this particular situation, and it just wasn't working for me. Yeah, I tried, I think, multiple times. So yeah, you would use a different tool, which we'll show in a sec. Yeah. So here I'm just trying to find out, you know, what's going on. You know, what am I doing wrong? You know, even though I'm, you know, I would say I'm quite experienced using this software, sometimes, yeah, I don't quite get it right. Yeah. And I just couldn't for the life of me think of why the Boolean tool wasn't working at all. So in the end, I do use the combine tool. Yeah, and that actually worked for me in this particular situation. Yeah. So usually if you're using a Boolean union, but in this particular situation, we use the combine tool. They're both slightly different. So yeah, once again, a bit of smoothing, just because I'm more comfortable doing it out, you know, in the software. But you could 3D print this and then polish it accordingly. Okay? And you would basically bond it on using any resin cement. Yeah. But they work very well, especially for a provisional. But you do need to have a degree of thickness to them of at least 0.7, 0.8 millimeters. Otherwise, they will absolutely snap at that wing. And yeah, I would have actually increased the size of that wing as well. And I like this exercise, actually. This is actually, if a patient is happy with the way that their denture fits, but they just want new teeth, then this is actually a nice use of the Medit Design app. So I've got a denture here. Patient is happy with the base. So I've done a scan of the denture itself. And then we're just basically removing digitally the denture teeth and putting or adding new teeth onto this particular denture. So it's just really one of those nice ways where if the patient has been wearing the same denture for many years, they just have worn teeth and they want new teeth, but they want to wear the same denture. This is one of the ways to do it. So you could also realign that denture, and as long as you're happy with the base of that denture, then of course you'd load your upper and lower scans in, lower scan in this case being a lower denture, and then digitally actually extract the teeth or remove the teeth. And then in this particular situation, I am filling up the holes. I'm using the fill hole tool because it doesn't need to be terribly accurate because we're going to add teeth on top. And you need a pontic library. So here I do already have individual teeth belong to a particular pontic library. And you load them in like so. All right, and they should appear in different colors. And you can actually, first of all, you'd move them as one whole body, kind of roughly to where you want them to go. And I'm using the transform tool, and you can scale them as well. Right. So yeah, just basically gross movements first, and once you're happy with the big gross movements, then you would individually move certain teeth, scale certain teeth to how you want them to be. Right. So this is it's very powerful software. Okay. So this exercise does require a firm understanding of the different weapons that you have available to you on this particular application, but it's really nice. Here you spend a lot of time. You'd probably be spending most of the time essentially using that transform tool, selecting individual or groups of teeth to move or scale wherever you want them to go. I'm not a technician, so probably some of you guys can do a better job than me, but it's just to give you an idea that it's actually possible using Medit apps. You don't necessarily need to use 3Shape or Exocad for this if you don't have access to that. For simple things like this, you could actually use Medit apps for this particular application. So yeah, a lot of time will be spent on changing the position of these teeth, moving them to where you want them to go. So it's just time essentially. And then once you're happy with where the teeth are, then you can shape the gums a little bit, and you'd shape them with your sculpting tools, adding, removing gum or tooth material. Really easy using this particular application. So if once again, the exercise really shows, or I guess highlights the transform tool better than pretty much any of the other exercises that I've shown today, because we're transforming or moving, scaling, a lot of teeth, not just one tooth, such as in the Nesbitt video or in the Maryland Bridge video. We're doing a whole row of teeth. So here, what I would actually recommend is that you could actually have some nice aesthetic. You can actually improve the aesthetics of the denture by actually bulking up, kind of like mimicking the root form of teeth using this sculpt tool. So on the facial aspect, you can actually deliberately bulk up where the roots of those teeth would be. Just makes it look nicer and gives the denture a bit more of a natural effect. But I don't think I do a great job here in this particular video, but I think if you want to do it in your own practices or in your labs, then that's what I would recommend. So here, adding a bit more material to cover that denture tooth. And then also in this situation, I think I'm removing some material as well. And then you can see some occlusal interferences. We're going to remove them as well. Once again, very easy to do with this particular software. So removing those occlusal interferences. Of course, once again, you could just 3D print this and polish it inside the mouth. they will probably still need to polish it inside or adjust it inside the mouth, but this just gives us, while we can do it on the software, then yeah, why not? And we're almost done with this particular playthrough and this particular exercise. So what's next is that we want the teeth to be in one piece. Denture teeth in one piece and denture base as one whole piece. So 2 separate bodies. So I'm actually overbuilding the interproximal contacts of the teeth because I want the teeth to actually overlap onto each other. Because when I use my Boolean function and merge all the teeth together, I don't want there to be any gaps at all. So this is one of those parts where it's actually probably really important to do, because if you have gaps in between certain teeth, now if that's intentional, then that's fine. But if you want your teeth all in one piece, then yeah, you definitely want to overbuild those contacts. And then what you want to do is you want to create an offset model of your denture teeth of about 0.1 millimeters, and then you're actually going to do a Boolean cut of that offset denture teeth file on your denture base. And then you'll see the little indentations on that denture base, and that will be your final denture base that you 3D print. Yeah, you can see those little indents there. And yep, here I'm actually printing this on the Sprint Ray Pro 55S out of their Apex denture resins. So once again, teeth and base separate, and then we're going to glue them together. Now, when I'm printing the teeth, I am printing them, so I'm actually orientating them with the occlusal surface facing towards the build platform. You definitely don't want the fitting surface or the surfaces that are being glued onto the denture base to be, you don't want any supports on those regions, because then when you adjust it, there's going to be a lot of adjustments and your denture teeth may not actually sit down properly. So a bit of loading, and so this is what I would not recommend, and this is why I actually correct it. So once again, don't just blindly trust any software. I've used software enough to know that sometimes what they give you is incorrect. So yeah, orientate it with the occlusal surfaces facing downwards, and so that will print. Printing out of Apex, which is a beautiful denture resin. It's nice and strong, very easy to polish. Aesthetically, it's very nice as well. So that's a product from Sprint Ray. So yeah, really, really nice denture resin. And then here we're going to do a second print of the denture base. Once again, using Apex denture resin, but this time in the gum resin. And I will be basically orientating this at a slight angle. So this is actually not too bad, the default orientation. And the software in this case is actually smart enough not to place supports within the fitting surface. So this is what they look like freshly printed. You'd actually squeeze them, insert them together, and cure them in the one go. And this is the final result. Just polished, no characterization done. Okay, so really nice product out that Sprint Ray has produced. And once again, Medit design showing you what's possible. And finally, indirect bonding trays. So for those who do a lot of fixed orthodontics, here I'm actually creating, I'm actually use a digital caliper. I measured out my brackets and I'm creating these little rectangles or boxes with those measurements. Now you would, as I said, use a digital caliper, and you'd probably add 0.5 millimeters to the dimensions. You definitely want to measure, the width and the height. And then as for the length, or I guess depth of the box, I've set it as 5 millimeters, and it won't make much sense until later on in the video. And you do that for each of the brackets, Now, obviously, you wouldn't need to measure all your individual brackets because for most cases, the brackets for the low end sizes are exactly the same. So you basically need to measure, the ones that have different dimensions, and then you can double up or duplicate them for the ones that do have the same dimensions. Loading my intraoral scans. Now this is an extraction case where I'm taking out 4 premolars, which is why I don't place brackets on the upper and lower first premolars, because those teeth have already been extracted. This is a bimaxillary protrusion case. So here, creating an offset model of my intraoral scans. And then basically you're repositioning each of those individual boxes to where you want them to go, right? Because a lot of indirect bonding tray software is very expensive, like 3Shape, Maestro. They're quite, unless you're doing a lot of it, it doesn't make sense for a lot of practices to invest in that. Whereas, this is a very simple way of creating an indirect bonding tray for any orthodontic bracket system. You just need to do a little bit of measuring yourself. The program that I used before, Tinkercad, that's also free to use. You can just basically, register for a free account, and then you just create little boxes and input the certain dimensions that you want. But once again, you just have to keep in mind to add 0.5 millimeters to give you a little bit of leeway, right, for you to correct or change things up a little bit. And then I've labeled each of those boxes, per tooth, right? And basically just repositioning them to where I want them to go. It's a bit of a lengthy exercise because you have to, move teeth individually, but it does work. I do actually have to credit this technique or this idea to a Malaysian dentist, Dr. Chong Guo Wei. He's a good colleague of mine, a good friend of mine in Malaysia, and he's also a big user of 3D printers and a big, supporter of using affordable software to create, dental, functions and applications. So yeah, if you want to follow him, look him up, Dr. Chong Guo Wei from Malaysia. Great work that he does. So I do have to give him the credit for this idea. I just thought, I saw this and I thought, this is actually a really nice way of using, the design app in Medit to its potential. So here we're repositioning one by one the brackets, and you just want to embed them just ever so slightly within the tooth, not too much. You want basically most of the box sitting external, and that's why you have that 5 millimeter depth that I mentioned at the start. Because what's going to happen is that after you've repositioned all your brackets, you're actually going to create a thickened shell of, first of all, you're going to crop your upper and lower models, and then you're going to create a thickened shell based off that cropped, version. And then you're going to do a Boolean cut, essentially, of the brackets from these shells. Yeah, so here we've done the upper, now we're going to do the lower. If you look carefully, you notice that I've actually put a little kind of like a smaller box on top of these bracket boxes. That's just for me, for my own reference, so I know that this is facing external. Rather than if you just have a simple box, sometimes you just get confused, what's in, what's out, what's left, what's right. So I put a little rectangle there, or I should say a little box on top of my brackets, just as a little marker for me to know that, this is going to be on the top, top right, always going to be on the top right, facing external. Yeah. So yeah. This is a bit of a test in patience because it does take a little bit of time. But hey, rather than spending several thousands of dollars on software, this is completely free for anyone to use. And then repeating the process for all the teeth in question. And the beautiful thing about this is that it is universal for any bracket system. If you're using an obscure one, it doesn't matter. If you're doing lingual, brackets, you can do it on here as well. Okay, we're just basically putting boxes on teeth, so you just need to get the measurements right. Here, the next step, once we're happy with the positioning, is basically trimming the extraneous data. Okay, I'm basically trimming, half of the height of the teeth. Right, we don't need the back teeth here, and then we basically want to create some sort of shell. So it's starting to look a little bit more like an indirect bonding tray now, I think. Yeah, and then here you want about 1.5 to 2 millimeters of thickness. Doesn't really matter. And you'd be printing it out of either indirect bonding tray resin or surgical guide resin. Up to you. In this case, I've actually printed out of surgical guide resin because I think it's a much easier resin to handle. It's much easier to clean, and it actually, I think, it is a lot more translucent compared to IBT resin. But if you wanted to use IBT resin, that's also fine as well. So yeah, I've done my Boolean cut my brackets away from my trays, and that's my upper one done, right? And now we repeat the same for the lower. So once again, trimming the excess data, and then doing that Boolean cut. Looks simple, right? But yeah, it is about, the more you use this software, the more familiar you'll get with it, and it's just about getting used to the different tools that you have at hand, and thinking of not ways how you can be restricted, but also thinking of ways how you can get around certain hurdles. So once again, Boolean cut function, and just make sure you choose the right brackets to cut, which is why I've labeled each of those brackets by tooth number. Okay, and that's ready to be 3D printed. And I'm once again using the Sega here because I really like their ultra gloss trays. I'm printing at 100 microns, and I'm printing them at a slight angle. There will be a few supports kind of like in that middle section, and I'm orientating them slightly so they won't have what we call these islands forming where there are unsupported parts of the trays that are running through the prints. So that's basically the principal reason why I'm angulating them slightly. And then, like with that other video I showed earlier with the bleaching trays, I'm actually sinking them deliberately below the print platform, so that the back two teeth will be cropped out slightly, and I will be adding a couple of supports. But that way, I don't need to really have too many supports that I need to polish off. Just a few supports in that central section for both the upper and lower trays, so that they print successfully. Yeah, our burn-in or bottom layers are limited to about 0.5 millimeters only. You don't really want to have too many bottom layers in this case because the bottom layers tend to be quite distorted, and you'll need to polish that off. And this is what they look like. I haven't polished them at all. That's what they look like just after being cured. They fit like a glove, and they're very transparent. So this is why I'm a big fan of Sega's ultra gloss trays, but Spring has their optical polish trays. But yeah, it's really great use of the technology that we have at hand. So in conclusion, you've seen a lot today with ClinCAD and mainly the design app. You just, I guess, I mentioned it earlier, but I just want to stress that especially with Medit design, it's just a bunch of tools. You've got your sculpting tools, your trimming tools, Boolean functions, combine functions, transforming tools, where you can move objects here and there and scale them. All right, so it's just a bunch of functions essentially, and really, what limits you is actually your imagination, rather than anything else. So the more you use this software, the better you'll understand the functionality, and actually you'll probably think of different ways to use this particular software, more ways than I could. And the beautiful thing about Medit software is that it's free. So like there's no financial investment into this software. You can get started, straight away. And really the only thing that you lose is a bit of time learning how to use it. But yeah, it's great software. I'm a big fan of the ClinicCAD, Splints, and Medit design apps. I think they're really powerful for what you basically pay for, which is nothing. So yeah, if you haven't started, start off with some simpler stuff first, and then move on to some more complicated functionality and applications. So yeah, thanks for your time, and I hope you took something out from this webinar. It actually was a longer webinar than I anticipated, but if you do want to reach out, you can see the links over there. You can scan that QR code. All my relevant links are there as well. And any of the videos on this particular webinar will actually be on my YouTube channel as well. So don't be shy. Feel free to reach out, and happy designing and happy mediting.
Okay, thank you for sharing all your tips with us, Dr. Andrew. So let's move on to Q&A sessions. Okay, so today we have 3 questions in total. So I'll start with the first one. Question number 1. Do you sometimes make flipper with 3D printed resin? How do you make the clasp area with tension?
I think that's a really good question. I have designed flippers in the past, and I still do it from time to time when the situation arises. So it's quite straightforward to do on Medit, although there's quite a number of steps involved. But they do work, and so I would generally print the denture base or the flipper base first, and the denture two separately, and then bond them together. Now, with regards to clasps and retention, you'd actually be surprised how retentive they can be. Because the way that we're designing them, we're not creating some sort of undercut model. So our clasps, when we design it on Medit ClinicCAD or Medit the design app, which I use most of the time, the clasps actually are pre-tensed already. They're under some sort of tension already because we haven't blocked out any of the undercuts. Whereas in an analog fashion, you usually have to pour up a model, you'd have to wax up those undercuts because you wouldn't be able to remove your denture. And I guess my experience is that you've got to actually be careful with digitally designed flippers because they actually may be too retentive because we haven't factored into any we don't have an undercut model per se which we're using to design our flipper on. That being said, if you do want to add just a touch of tension in your flipper, I think actually the easiest thing to do is actually print out your flipper and then just with some gentle but consistent force actually push that clasp inwards, and then when you cure it in your proper light curing unit, it will actually come. There'll be some tension when you pop it in. But in my experience, generally, when designing it myself, the retention is actually more than sufficient because I haven't blocked out any of the undercuts when designing such an appliance.
So what exactly is the material that you're using for the base part with the clasp? Yeah,
so there's many materials out there in the market. You can use like just traditional denture-based material, comes in a pink color. But I guess for some users, you've got to be careful. You can't print it too thin, but because it can be quite brittle or fragile at very thin sections. Alternatively, what I've seen other people do is actually they print the denture base in a clear splint type of material, flexible splint type of material, like Key Splint Soft, or there's other brands out there in the market, and then you can paint that or stain that pink with pink composite stains. If you really want to have that gum color, generally speaking, if it's temporary, I wouldn't bother. But if you did want to have that pink color when you're printing something like this, you'd probably stain it afterwards, after it's printed. I found that actually works as well. Yeah, because it's a little bit flexible, it's also a little bit more comfortable and a bit more forgiving. So if if it's not as stiff as your traditional denture-based material.
Okay, thank you for answering about it. Okay, question number 2. How many kinds of resins do you have in your clinic? How do you manage the resins based on their usage?
I have a lot of resins in my clinic.
Wow.
I think just for one of my printers alone, I have more than a dozen vats full of different resins. Each one of them a different resin. That's just one brand. But generally speaking, I would have a container or a vat per resin. I don't try to mix and match. It's messy. You waste a lot when you're exchanging it. It's just better workflow if you just have a dedicated vat per different resin or for each different resin. But all you do is, you just have to store them, away from light, away from dust. I have, a cupboard basically full of resins. Each one of those containers is light proof and dust proof, and they're all labeled with what is inside. So that's how I manage it. But I generally will have a different container or a different vat per resin that I use. So yeah, I have dozens of trays and vats full of resin stored away in my practices.
I just don't know much about the 3D printed resin. So after 3D printed, after 3D printing, you need to put in the liquid afterwards, right?
Yeah, you have to wash it basically. Just
Yeah,
like
so
if
use the same one?
if you finish a meal, you have to clean the plates, right? So you rinse it under the tap. Similarly, when we print like an appliance or crown or a splint, it's still coated with the wet resin. So you have to wash that usually with alcohol. And once that's dried and cleaned, then you would put it under some sort of polymerization curing units to make sure that that appliance achieves the properties that you want. So that's generally the 3 steps in printing in terms of the physical workflow. So you're printing first, then you're washing and removing the supports, and then you would finally cure it once everything is nice and dry.
Okay. Okay, we're left with the last question. Question number 3. Is there any clinical tip when attaching supporter? Do we need to consider the supporter thickness as well?
I think the supports are really, really important. And a lot of print failures that I've seen, on social media and everywhere is a lot of the reason behind it is because of poor supporting or poor placement of supports. I think if you use a dental 3D printer, they've got big brands out there. I don't need to name any, but generally, if you start using a dental specific system, the preloaded configurations or settings for these supports per appliance, per resin, they're already generally configured for you. So there's not much I guess thinking required. But if you're using, let's say, like a consumer level printer, not specifically dedicated for the dental industry, then really it's up to you to know what to use and where to use it, how thick the supports need to be, or how thin they can be. Every time you put a support in, of course, if you want it to be secure, you can place heaps and heaps of supports and you'll have a successful print. But every time you remove a support, it leaves a scar behind on the surface of your printed object, which you have to polish off. So there's always a fine balance between having lots of supports and then securing your print, or having less supports, but then you have less post-processing required. Always a fine balance, and part of it is a bit of experience and knowing what will pass and what won't pass. After thousands and thousands of prints, I think I have a pretty good idea of what works and what doesn't work. But for some users, especially if they're entering 3D printing, without any prior experience, yeah, it can be quite daunting, and it's always good to wherever you get your printer to ask for help or ask for advice, especially at the start. But my recommendation is that, generally speaking, if you are sticking with dental specific 3D printing systems, most of your support settings are configured to an optimum sense. So you don't need to necessarily worry about that too much.
Okay, that was the last question. So that's all about it for today. If you have any questions, simply leave the comments below the video. And thank you for being here, Dr. Andrew.
Always a pleasure.
Bye-bye. See you next time.
See ya.